All right, so let's try an example, and we'll try to see if we can see where the function's increasing or decreasing, and then figure out where we've got maximums and minimums. So what I want to know is f prime of x. So that'll be 6x squared minus 6x minus 36. And I can, I want to set this equal to 0 in order to find critical numbers. So let me first just divide everything by 6. If I do that, I've got x squared minus x minus 6 equals 0. And if I factor this out, I get that x is equal to 3, x is equal to negative 2. Now, these values here are critical numbers. That means that any relative extrema are going to happen at one of these two numbers. So the way that I like to set this up is I use a table that came from your textbook. So I will put my critical numbers, I've got one right here, negative 2 and 3. So I list the critical numbers kind of outside the table on these dividers, right? So where these split. And that's going to split up my interval. So if I think about now the x-axis, we're saying we're interested in values at negative 2 and 3 on the x-axis. Well, I've got negative infinity out here and positive infinity here. So my x-axis is now broken up into 3 intervals, right? So this first one goes from negative infinity to negative 2. Second one goes from negative 2 to 3. And this third one goes from 3 to infinity. Now I'm going to pick a test value. And a test value is just any x value that's in this range. So try to do some colors. If I'm in this range here, I could pick negative 3, for example. So I would put negative 3 in here for my test value. If I go into this space in here, I could pick 0. 0 is in between negative 2 and 3. So I would put 0 as my test value here. And then if I go in this space, I can pick 4 is in between 3 and infinity. So I pick 4 for my test value there. And so now what I want to know is what is the sign of f prime of x with these numbers plugged in. So I'm going to take this 3 and I'm going to plug it in to my derivative. I can do it here, I can do it here, I can do it here, it doesn't really matter. Well, it looks pretty easy to do it here, right? If I plug in, I've got negative 3 times, minus 3 is going to give me a negative number. Negative 3 plus 2 is going to give me another negative number. If I multiply those together, I'm going to get a positive value. Moving on to the next one, if I plug 0 in here, I would have negative 3 times a positive 2. That's going to give me a negative value. And then I'm going to take 4 and plug it in for both of those x's. And so I've got 4 minus 3 is a positive, 4 plus 2 is a positive, positive times positive gives me a positive value here. So my conclusion is that this graph is increasing here, it's decreasing, because the derivative is negative here, and then it's increasing again over here. So if I wanted to write that out, I could say that f of x is increasing on negative infinity to negative 2 and 3 to infinity. And I could say f of x is decreasing on the interval negative 2 to 3. Now, one other thing to check. Look right here. At -2, I'm switching from positive to negative, right? As I move across here, I've got a positive value switching to a negative value. That tells me, based on the first derivative test, that I've got a maximum right there. So this positive to negative switch, I can write down here, I could say f of x has a relative max at x equals -2. Let me write that a little cleaner. And then here, if I look at this one, I'm switching from negative to positive. That's at x equals 3. So here I can say f of x has a relative minimum at x equals 3. And these are all my conclusions that come out of this graph, or out of this table. It's kind of a nice way to figure it out. If I were to sketch this graph, it says that it's increasing, reaches a maximum, decreasing, reaches a minimum, increasing. And then if I were to put this on x-axis, I don't know how high or low it would be on this x-axis. So this, this could be up here, down here, whatever. I don't know about that part. But I do know that this value right here is -2, and this value right here is 3. So, somewhere in here, I can have a y-axis. Here's the actual graph of what it really looks like is on here. So you can see that our shape was accurate. The key points we came up with right here, at -2, there's a maximum that we found by looking for that derivative was 0. We found over here at 3, there was a minimum that we found by looking for where that derivative was 0. It's in between these two, we're decreasing the whole way, right? And then we've got sections that are increasing over here. The graph is increasing, and here the graph is increasing. So it's kind of cool to see it all work out.